This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson, this should say 6.2. We're talking about co-functions. So if you want to go ahead and open that up, we are on 6.2b. Okay. Whoops, that's a silly looking 6. Okay, so we left off on example 3 in quadrant for part D. Okay. So D said to state the quadrant in which 2 theta lies. Okay. We were given the information that tangent theta equals negative 3/4. So we need to use that information to determine where 2 theta lies. So since 2 theta is sine of 2 theta, we found to be negative, and we're going off the information that we had last time. Sine of 2 theta we found was negative. Okay. And we found that cosine of 2 theta was positive. So we know that 2 theta, because of this, has to be in quadrant 4. Okay, sine is negative, so here and here, and cosine's positive, here and here. So that means we are dealing in quadrant 4. Okay, so that's just a quick reminder from last lesson. We're going to move on to the newer stuff now. Okay. So we're going to start right off with example 4. Okay, and example 4 says find an equivalent expression for each of the following. Okay. So A, we're talking about sine of 3 theta in terms of function values of theta. And then B, we're going to find cosine cubed x in terms of function values. Of x, or 2x, raised only to the first power Okay, so let's start with A. Sine of 3 theta. All right, so basically we want to take sine of 3 theta and split it up into a way that we are used to seeing it. Now, I know about sine of 2 theta, and I know about theta. So what I can do is I can break this up into sine of 2 theta plus theta. Okay. So now what I'm able to do from there is use my information and split this up. Now, this is going back to the identities we've been using for the past couple of lessons. This is my sum. Okay, we had our sum and difference identities. We're going to use our sum of sines. Okay, so this is u and v, right? It's going to be sine of u, sine of v, plus cosine of u, cosine of v. So we're able to break this up. Sine of u, cosine of v, plus cosine of u, sine of v. Okay. So now our next step is to deal with these sine 2 thetas and cosine 2 thetas. We have to figure out what to do with these pieces here. Okay. So now sine 2 theta is a simple one because I only have one option for that. We know sine 2 theta is 2 sine theta cosine theta. And then we have to still include our cosine theta. Plus. Now cosine 2 theta, I have a little bit more because I have those three options. Now, I think I'm going to select my 2 cosine squared theta minus 1 times sine theta. And the reason I'm doing that is because this is going to give me cosine and sine, where over here, notice I'm going to have cosine and sine. So now I'm going to do a little algebra. 2 sine theta cosine squared theta plus, gotta distribute, 2 sine theta cosine squared theta minus sine theta. So what I have here is 2 sine theta cosine squared theta plus 2 sine theta cosine squared theta. And what happens there is that we have to combine our like terms, so we get 4 sine theta cosine squared theta minus sine theta. Okay. We could also substitute cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta for cosine 2 theta. It's going to lead to different results, but they're all going to be equivalent. Okay? And since we wanted this in terms of function values of theta, that's exactly what we've done. Okay? Just thetas. Theta, theta, theta. Okay? All right. So let's look at B. And B was cosine cubed x. Okay, so essentially what we need to do is we need to break this up into a way that we're used to seeing it. So we could say cosine squared x times cosine of x, and we know that that would give us cosine cubed x. And this is going to allow us to use the identities that we've been given to kind of simplify this out so that it can only be raised to the first power. So this is already raised to the first power. This cosine squared x is what's concerning me. So one of our identities states that cosine squared x is equal to 1 plus cosine 2x over 2. And again, you should have your note cards out so that you're constantly looking for these connections, okay? Times cosine x. And then what I have to do is multiply this through. So cosine x plus, sorry, I keep losing my lines here, I don't know why. Cosine x times cosine of 2x. And I can't multiply those together because of what's inside here. I've got an x and a 2x. I can't combine that. And that's all going to be over 2. So now I've got everything raised to the first power. Okay, so the last thing we're going to talk about is half angle identities. Okay, our half angle identities if we take half of an angle of some angle measure x, the new angle measure will be x divided by 2. It's just taking half of the angle. Okay, so we do have some half angle identities that kind of simplify things out for us. So again, make sure that you have these written down. So we have sine of x over 2 equals, we have 2 plus and minus the square root of 1 minus cosine x over 2 cosine of x divided by 2 equals plus and minus 1 plus cosine x divided by 2. Tangent of x divided by 2 equals plus and minus the square root of 1 minus cosine x over 1 plus cosine x. Other options for this one, sine of x divided by 1 plus cosine x. Or 1 minus cosine x over sine x. Okay, so please make sure you have all of these half-angle identities written down on a note card for use for later on. All right, so let's take a look at example 5. Example 5 says find tangent of pi divided by 8 exactly. Okay, so remember, exactly means I don't want decimals, I want fractions, I want radicals. Okay. All right, so what we're going to do is we're going to take pi over 8 and we're going to break it up so that it can be written in terms of a half angle. Okay. So tangent of pi over 8, I know pi over 8 is the same thing as half of pi over 4, just like an eighth is a half of a fourth. So I can rewrite it like this, tangent of pi over 4 divided by 2. So now what I'm able to do is I'm able to go to my half angle identities up here and select one that's going to work for me. I'm going to select this second one because I don't really want to play with the radicals, and it's just my first option. So I'm going to plug right into there. Sine of x, and x is going to be your pi over 4, divided by 1 plus cosine of pi over 4. And again, you should know these off the top of your head. Sine of pi over 4 is radical 2 over 2, as is cosine of pi over 4. Okay. So this, I have radical 2 over 2, and of course I need a common denominator here, which we know is going to be 2 over 2. So I get 2 plus radical 2 over 2. Complex fraction, we multiply by the reciprocal of the denominator. Those 2's cancel. So we wind up with 2 square root of 2 over 2 plus radical 2. Now my problem is here, I don't want to leave this with a radical in the denominator, so I do have to rationalize this. So what I'm going to have to do is multiply by the conjugate. The conjugate, we know, is 2 minus radical 2 over 2 minus radical 2. We're going to distribute in the numerator 2 radical 2 minus 2 over. Now remember, when we multiply by the conjugate, those center terms are always going to cancel, so we really only need the first and last. 4 minus radical 2 times radical 2 is radical 4, which is 2. Or 2 radical 2 minus 2 over 2. One last step, we're going to simplify. This has to divide into both pieces here. We get radical 2 minus 1. And that's your exact value for tangent of pi over 8. Okay, we're going to do one more. Example 6. We're going to simplify. So we've got sine x, cosine x, over 1/2 cosine 2x. And b, we're going to do 2 sine squared x over 2 plus cosine x. All right, so we're going to take a look at this one first. The first thing that pops out at me is that 1/2 in the denominator. Essentially, what's happening here is I'm dividing by a half. And we know that dividing by 1/2 is the same thing as multiplying by 2. So what I'm going to do is I'm going to simply multiply this whole thing by 2 so that I can clear that. So 2 sine x cosine x over cosine 2x. Okay. Now, I know 2 sine x over cosine x is an identity. Okay, that's sine 2x over cosine 2x. Now, sine over cosine is tangent. It's okay if it's 2 times the angle. That's not going to make a difference. Okay, so it's going to be tangent of 2x. We're just going to keep that in there. Last example. 2 sine squared x over 2 plus cosine x. So, again, I have this piece in here. Okay? I can adjust that. I know that sine of x over 2 is equal to its identity, okay? So what I can do is I can replace that, and because it's squared, I'm just going to simply square it, okay? So this is going to be replaced with 1 minus cosine x, and generally it's plus and minus, but because I'm squaring it, we know that negative simply becomes positive, so I don't need to put that plus and minus. If you'd like to, you're more than welcome to. So what I wind up with here is 2 times 1 minus cosine x over 2, because when I square root simplifies out for me. 2 and 2, that's going to cancel. 1 minus cosine x plus cosine x. Or 1 minus 2 cosine x when I combine like terms. Oh, I'm sorry. My bad. Negative cosine plus cosine. These cancel, and I'm left with just 1. Okay? So again, please make sure that you take down any questions that you might have. Come prepared for class, and I will see you tomorrow. Thanks, guys.